Hello everyone. Previously we have seen the insertion sorting algorithm and pseudocode, right? Now let's quickly write the JavaScript specific implementation and validate the same thing with one or two arrays. So here I have the class ready, right? So in this class what I will do is I will simply add one function called insertion sort. What it does, it will take the array of values. Let's assume that it is going to take it inside a variable ARR. Now our aim is to sort this array of values in the ascending order and return it. Okay. So here what I will do, if you remember the algorithm that we have discussed earlier, what exactly we will do? We will divide the array into two parts, right? First is sorted part and the another one is unsorted part. So our aim is to pick up the value from the unsorted part and put it onto a appropriate position in the sorted part. So whatever the appropriate position that we have, after whatever the values we have till that point, we will move them to right by one position. So in the beginning we have a simple array, and how would we get two parts, right? One is sorted part and another one is unsorted part. Basically, if you think of any array that can have only one value, it itself is a sorted array. So what we do is, to identify the sorted part inside this array, we will assume the value at index 0 is a sorted part. So our iteration that need to run on unsorted part is basically from 1 till the very last value we have on the array. So for that, what we will do is, we will write a for loop, let I equal to 1, I less than whatever the array that we have, dot length. In each and every step we will need to increment it by 1. Now what we need to do, whatever the value we have at this I, we need to move it to the proper position on the sorted part. So for that, what I will do is, I will simply keep couple of values here. So temp, let me just store the index, which is nothing but I. Similarly, let me just store the value we have at this index. So let me just call it as temp value, and this is nothing but whatever the array that we have value at ith index. Now what we need to do, the sorted part is present. Now we need to find the appropriate position for this value. So for that, what I will do is, whatever the temp index that we have, it is greater than 0, and whatever the temp index value that we have, if it is less than whatever the value we have at previous index with respect to temp index. So array of temp index minus 1. If this is the case, what we need to do, whatever the value we have at this temp index minus 1 is greater than whatever the value we have at this point of time. That means this temp value should come on the left side of this value we have at temp index minus 1. That is the reason why what we will do is, whatever the array of temp index that we have, we will simply update it with the value we have at the temp index minus 1. So array of temp index minus 1. Now we have successfully moved, right? So the next index that we need to compare is decremented by 1. So temp index will simply decrement by 1. Okay. Once this while loop is completed, right, we will have a vacant position for this temp value inside this temp index variable, because we are moving all the greater values than this temp value to right by one position by doing this updation. So what we need to do in the end, all we have to do is array of whatever the temp index that we have at this point of time, we will simply update with the temp value. Okay. Once this for loop is completed, what we need to do, we need to return whatever the array that we have, because we have sorted the array in the given input array itself. Okay. So that is another thing that you need to observe here. Okay. So that is a insertion sorting algorithm. Now let's quickly go ahead and test this out. Let me just create the object of insertion sort class that we have, and let me just do the console.log of, let me remove this console.log of is dot whatever the insertion sort function that we have. So let me just create a new here. So is dot insertion sort, we need to pass array of values, right? Let's assume we are passing 1, -10, 12, minus 90 and 1. Okay, now let's run this out and see the output. Let me just quickly run the code, and if you see, the output is basically sorted in the ascending order. Okay, similarly you can do whatever the values that you want. You can only pass array that has only one value, which itself is sorted, right? So run the code and we've gotten it itself. If at all, if you want to add some null validations that array is empty and all those things, you can put them as well. But the implementation that I have done is basically assuming that array will have at least one value in it. Okay, like that you can go ahead and convert this ascending order insertion sorting algorithm into descending order also by simply doing insertion sort. Let me just modify the function name to descending. All we have to do is change this comparison to greater. Okay, so if we run this now, let's insertion sort descending. Let me just pass the values of minus 10, minus 90, again 100, and let's just test this out now. So if I run this code now, if you see the output, the array is sorted in the descending order. Okay, so that is the JavaScript implementation of the insertion sorting algorithm based on the pseudocode and steps that we have discussed in the earlier videos. Okay, thanks for watching this one. Next sorting algorithm that we discussed will be merge sorting algorithm. I'll see you in that specific discussion.